Doing the video thing is a little complicated. It makes it a little bit more challenging than just attending to the folks in the room, you know what I'm saying? But we are just seconds away from having this. Thank you. Okay, I'm talking. Testing 1, 2, 3. I don't know if they're hearing me yet.
Hello.
Hello, testing. Sibilance. I mean, at this point, we could probably just use the laptop microphone and it would pick up from the speakers.
Well, I mean, if I'm sharing my screen, I need to do that, don't I?
Yeah, actually, let's just do that. Yep. Wait, no, that's not right. Backstage link? No, what? Yeah, from there. Why did that go there? What? I don't understand what's happening right now. That's not what it did before.
No, the one that you showed me. Do you want to just like email it to me or something? Because before it was your computer. Maybe you need to send it.
It was my computer before?
Yeah. Maybe you need to just send it to me or a different.
Are we good? We're good. Okay, so now the only thing is the backstage link. We can't get that to work.
Do you want to just Slack it to me? Slack it to me, and then
it's the same link. I understand. I think maybe I'm just going to log into the GDG or something.
Okay.
I don't know why. Is it because you're not on the Wi-Fi anymore or something?
I am.
No, you aren't. No.
You have it?
Seriously?
Yeah. This two-factor works.
You wanted the 2FA first?
Weird, right? Join event. That's right. Okay, so now I...
Oh, mute yourself. Mute your computer.
You guys are being... You're broadcasting.
Yeah, we weren't intending to, but thank you. Okay, so you're good now?
Okay.
I think we're ready to get started. I'm going to introduce you.
How do I share from here, though? No.
What?
Stage? Like, I'm in this event. I can't share.
Oh, I think we have to make her, Linda needs to make her a host. Okay. I'm having a little technical difficulties. Oh, it's me now, though, right? I'm logged in as me. I should be a host. There we go. Microphone and camera are disabled. You will not be able to present. We can't present into the bevy. It's Lucas is logged in. Great. And how about sharing the screen? There's no screen share.
Oh, he's not seeing screen share anymore. He says
I have record and stop broadcast.
record and stop broadcasting. Don't hit stop, whatever you do.
I know. Stages, agenda, code of conduct.
Sets off five writers. How are you sending? You're sending it now. You have to accept that.
It says I'm no longer a host.
He accepted the invitation. Is it working now?
No, where's the button?
At the bottom. Are you seeing the bottom of the screen?
Yeah, there's no share.
There. Next to record.
Those buttons all went away because she said I'm not the host anymore. It said you're no longer the host.
He got a message.
Okay, now you're the host. Enable. Microphone and camera are disabled. You cannot present, but you can still moderate. It says microphone and camera are disabled. Is it? Oh, it's this. It's this.
Rabimba? Who's Rabimba?
He's another speaker that we
Can
have.
we have Rabimba? Can we use Rabimba's laptop? Can we use Rabimba laptop?
Do you just need slides?
No, I have it saved.
You have a presentation of it?
Yeah.
Yeah, okay.
But I can send it.
You're no longer a host, it says.
He's accepting everything you said.
You are no longer a presenter. You are now a presenter. But I think
Here we go. Share screen.
No. So share now.
I do see
there,
the
but not
button.
possible.
Is it? It's probably some Chrome
Yeah.
permission setting.
Okay. No, not easily. She doesn't have.
Yeah, we don't care about the camera. So
Do you want him to just go first?
I guess we could do that.
Yeah. And I can send it to someone in the
Okay.
meantime.
Okay.
You want to speak to them?
Do you want to go first?
Yeah, and if you want.
Do you want to? I mean, like that, because your computer is already set up. You already know how to join.
Yeah.
Okay, so let's do that. Yeah. Okay, he's gonna come up.
Yeah, we're gonna switch.
Okay, so just unplug your computer, and then we'll figure that out separately. Yeah. Okay, we just have a slight change of order here. We're having a little technical difficulty with the first speaker, so we're just switching the order. So Rabimba is going to start us out instead of finishing us out. And so that will just be one moment. He's just grabbing his laptop, and he's going to come right up here, and we should be all set. So thank you very much for your patience. And we will be with you shortly. Yeah, that's fine. This is my laptop. Yeah. Rabimba. I'm not on Slack right now on this computer. Can you email to lukewarm at Gmail? Oh, because you're logged into my computer. At least I have a speaker slot up. Yeah, but where's Rabimba? He just disappeared. I just talked to him. He was right there. Okay. I did not get it. Lukewarm at Gmail? I didn't receive anything. Okay, he's coming up right now. Okay, folks, we're just about to get started. Rabimba is going to be speaking first, and so here he is. He's got a mic, I've got a mic. Thank you, everybody.
Which probably is working. Okay. Yeah, sharing weight.
And we just need to make sure we get you on the backstage as
Yeah.
well.
Provided I can see where my. Okay. And.
There we go.
Hello. Hello.
Okay, we're ready.
Okay. I'm waiting for heads up.
Yeah, good to go.
So, hi everyone. Hello. Welcome to today's first session, which was supposed to be the last one, but here I am. So today I'm going to talk about a little bit about WebGPU and generative AI. How many of you are here for the word generative AI? And how many of you are here for WebGPU? Interesting. So, hi, I'm Rabimba Karanjai, and I'm a Google developer expert in web technologies. I used to work in web immersive WebXR, web immersive reality with Mozilla back. And the reason I'm here today is to talk about browsers and the powers it has and WebGPU And since I know most of you will be interested in generative AI, I put that in my slide so that you can come to the room. But yes, we are going to talk about generative AI as well. So that's me, that's my friend, which I don't have anymore. So what we will be covering in today's talk is why WebGPU is being developed, compare some of the existing things, WebGPU with WebGL, and also why today it's possible to have complex machine learning tasks available and run in your browser itself. First, let's talk a little bit about WebGL. How many of you have used WebGL as a developer or as just a normal user? How many of you are familiar with it? Awesome. How many of you have played any browser game anytime, like in last 5-6 years at least? Or watched any kind of animation? So you all have used, or like have witnessed what WebGL can do. After maybe what 6, 7, 8 years, when Flash is not maintained anymore, I won't say died, the only way you can have any kind of rendering pipeline in web in your browser is through WebGL. What is WebGL? WebGL stands for Web Graphics Library, and WebGL has been incredible for enabling this widespread distribution of real-time 3D contents. It is already pretty powerful. And the fact that it's available in any major platform, every browser, and that makes it incredibly powerful tool to build your experiences for your users on top of that. But it also is definitely showing its age. WebGL have been web's kind of de facto GPU for almost 11 years now. And OpenGL itself was released almost 30 years ago on top with what WebGL actually utilizes. So it is managed by the Kronos group, and it has been there for a long time. So it has started to kind of show its age. So real-time graphics also has evolved since like last 30 years. The hardware, just as an example, the hardware which is used to produce the image on the right, any idea how much it would have costed like maybe 30 years ago? So roughly 30 years ago, it would have costed you roughly $253,000 to produce that image. Any idea what it will cost you if you want to render something like this on today's PC? Good estimate. So if you go to your Target right now, you will probably buy a machine with worth $500 and which will produce better images like this. And if you really want to be in $300, maybe Black Friday even will get you there. So in order with keep up with the increasing capabilities of our hardware and the developer demands, the APIs we have for our GPUs in web, that is not good enough. So here I actually showed like 3 kind of APIs, APIs what you can use for tapping into this power in GPU. So we have Vulkan, we have DirectX 12, and we have Metal from Apple. Each of these gives you capabilities to tap into the GPU and work on top of that. But unfortunately, WebGL cannot keep up with it because it wasn't ever supposed to be a GPU library. It was supposed to be a graphics library. So how you actually utilize WebGL to do graphics computation involves a lot of overheads. There is no direct memory share. You have to pass every task twice and those kind of things. So while it has served us well, we need to go past it and see how we can actually bring this experience, web native experience, to tasks which are GPU specific, for example, machine learning, why we are here today. So why WebGPU? WebGPU is supposed to be the modern GPU API for the web. It has modern features, or I would argue it has web native features. What do I mean by that? So what are the new WebGPU features? So some of these are compute shades, improving debugging features, which is very like dear to me, and render bundles. We are going to talk about most of these in this talk and how you can utilize it and how it enables us to have the experience we are going to have today here. Now, when I say new, this is new related to like relative to how WebGL was. These are not really new if you are a graphics developer. Any of you here actually works in directly with graphics APIs? Okay. In my last talk, there was somebody, and he was like, what do you mean by graphics developer? I directly make kernels. I'm like, okay, you are like, I work much after you are done. So a couple of demos, if you want to take a look at. So these are utilizing web GPUs. If you go there, you can kind of play with it, see what the performance is, what the latency is, but that's not what we are here today for. Can we utilize this? And let me do something if I can. So can we utilize this to have native experience for complex models, rather pretty complex models? Like we said, like we saw in the other room, that generative AI is a pretty hot thing right now, right? So shouldn't I be in good internet? Yeah. So it's supposed to be very hot right now. It is running, right? And if we can run these incredibly complex generative models directly in browser, that means, yeah, we have come to a stage where we can directly have these using web GPUs using in our own machine. So this is a demo where I'm running stability diffusion directly in a browser in Chrome, more specifically, and we can see that it can produce an image. It still takes time, but it can produce this directly in browser using just on your device APIs. And this is not using internet at all once you have the model. So that's interesting, but there are caveats. Before that, I'm not here just to show you the demo. I am also here to show you how you can build this, which, if you want, this demo I just showed, you can actually try it in your own machine. There are caveats, which I'm going to talk about, but it's right now live in this URL, or you can scan this QR code. Once you are done with that, the caveats. This, since it's running directly in your machine, you will need a graphics card which has a minimum amount of VRAM. For this demo, at least, you will need something with 8 gigabytes of VRAM. So if you have Apple M1 or M2, this will run it. It will be slow. So per image will take roughly 90 to like 1.5 minutes to 2 minutes to produce that image. But it is possible, so it's do it. And if you have any other machine with the NVIDIA graphics, maybe this will be a little bit faster. But we want more. That's not good enough. So can you do it for something else as well? So this is a demo where we are running like text model, that's an LLM, kind of like ChatGPT. Of course, not ChatGPT. And this is running completely in your browser. You can ask. So I just asked it. I also need to make it faster. So can it write a song for GDG Cloud Boston? Let's see. So this is running completely in my browser and without any internet connection. And you will see that if it works or not. If you want to try this one, this has much like low requirement. So if you don't have a machine which can run the stability diffusion model, you can play with it. So if you scan this QR code or go to this website, you will be able to choose 3 models. Do not choose the Falcon model unless you have a good machine. It requires the same 8 gigabytes of VRAM. But the model I am choosing right now, that will run even if you're native GPU. So I'm running it in a 2016 Intel Mac, and it runs completely fine. And I'm also going to show you a live demo to show you that, okay, this is not going to internet. I'm running it completely in my machine. So that's a song. I don't know if you can sing it. Yeah. So with that, how did we actually achieve it? Now, when I said that we can have these kind of experiences, I kind of cheated a little bit. It's not directly I'm writing everything in browser. though everything is running in a browser, I'm utilizing an open source project called Apache TVM. What TVM does is that you can take a specific machine learning model. I work in web. I'm not a machine learning. I'm just an enthusiast. So what I did was that I took an existing model, and TVM can compile it in JavaScript. And TVM runs a complete virtual machine using WebAssembly. This project was there before. This is a Carnegie Mellon research project. This kind of experiences were not possible before because the web didn't have a API powerful enough or responsive enough to pull out experiences like this. Now it has. So how the architecture more or less looks is like this. You can have any kind of models like this. You run it through TVM. TVM generates this file or this JavaScript file, which it will run inside its VM. So that stability diffusion JS is actually running the whole model. And TVM is completely running in a WebAssembly inside, which is utilizing the WebGPU to provide you this kind of experiences. Having said that, how much performant it is? So this is just an example in Chrome that when you run TVM with the WebGPU, that's how performant it is compared to the previous models, even in native. You will see TVM native in OpenCL and Metal, we are kind of reaching that same level of performance in web. And that is making us, enabling us to make these kind of experiences available. Now, I talked a lot about, since we have these experiences, now coming back to WebGL and WebGPU. Now, since I got your attention that you can build these kind of experiences, let's talk about how you can. So when I said WebGPU and WebGL, why not WebVulkan? Vulkan has been a library for quite some time. For starters, if you're familiar with a library like with an API like OpenGL and go looking for examples in Vulkan, it might be pretty intimidating. Why? So if you look at this, I shamelessly took it from a tweet, but I thought this was great for the talk. So if you look at this, you see first we have the DirectX 9. This is just number of lines for the implementation. In DirectX 9, it was small. In 11, it was a little bit bigger. In 12, it became a little bit bigger. In OpenGL, you will see the same, that version 1 was smaller implementation, 3 had more lines of code. Vulkan, on the other hand, is still going. So it is intimidating. It's pretty hard to actually understand what's going on. It's even harder to actually implement it. Now, why Web API? Aside from complexity, there's a different set of goals we are looking for. When I say Web API, for any kind of experience, including machine learning, there are certain fundamental expectations out of it. First, it has to be like deterministic. There can be no undefined behavior. It also has to be sandboxed. It also has to come with explicit user permission for anything it does. The native APIs are built on completely different set of expectations. They're more like they are built with their expectation that you can share data with other APIs, you can share data with other states. Web APIs are built with expectation that, okay, these has to come with certain security features and certain web-specific sandboxing, which makes it much secure to do this in web if you are if your application has that kind of expectation. So WebGPU, I would argue that it has been explicitly built to serve the needs of the web platform. So this remove complexity where it doesn't make sense for the web. It uses the specific patterns web developers are already familiar with. Now, this is a very small Hello triangle example, like just a triangle Hello World. So since it's a graphics library, instead of Hello World, I have a Hello triangle. This just creates one triangle. On the left, you have the code to build it in WebGL. On the right, you have the code to write it in WebGPU. But I have been advocating WebGPU for now, and now I show you the code which is larger than WebGL. What's going on? Let's look at a comparison of how WebGL and WebGPU accomplishes the same task and why we want to go there. So the first aspect of the both of them is that you need to interact with it. In WebGL's context, WebGPU is just a device. It's right out of the gate. And on the right, if you see that if I implement the same thing, WebGPU takes more number of code. But buffer management looks pretty familiar as well between the two APIs. The biggest difference being that WebGPU takes in a size and usage of the buffer at creation time, which are immutable afterwards. And also notice we don't bind the buffer we want to operate on. So these, and we just pass it as an argument. These are the patterns you will see repeated throughout these APIs. For shaders, now we see a little bit different. The big change is that WebGL uses GLSL and WebGPU uses a new shader language called WGSL, pronounced Voxel. Now, this is designed to be cross-platform nicely. So if you have already coded in WebGL, you should be able to be you should be very familiar with how to do that. Just to note that with WGSL, the fragment and vertex shaders can be part of the same shader as long as they have different function names. Now, there is no separate program in the WebGPU like there is in WebGL. The shader program is linked in part as much as the larger object called a pipeline. We will talk about pipelines later and see that what we can do with them. So if you want to kind of play with it, your first WebGPU application, just go here. It's in glitch. You can just remix it. You can play with it, and you will be able to build your application. Now, why is WebGPU more efficient? And why did I even tell that it takes more line of code? What's going on? So looking through the previous code snippets, there are a lot looks pretty familiar, but WebGPU had more. So if I want to explain it, let me explain with an example of a sandwich shop. So imagine WebGL is a sandwich shop. And then what you do is that you go to that same shop again and again, and you pass an order there. So every day you walk in and order a same sandwich from a waiter, and who passes it to the kitchen. In the kitchen, it's a different matter altogether. The situation is very complicated. The chef doesn't speak the same language as the waiter, so the waiter as you. So waiter has to translate it in a way that the chef understands. It has to get the ingredients, and certain sandwiches also after it's made, it has to be checked for quality control that okay, it meets your standard, like what you expect from the sandwich. Obviously, that's a lot of responsibility for the waiter, and the quality of the speed of how your sandwich gets made is also based on how good your waiter is. Just to be very clear, the waiter here is your graphics driver. Now, one day, we have a new WebGPU Dall-E opens up which next door. And now they have a very weird process. All orders must be submitted in the front desk before like you actually go in, it's in advance. And once your order has been submitted, you are assigned a number, maybe the order number 53, and next after that, you get the sandwich. Feels like a lot of overhead for that, right? The interesting thing is that the next time you come in and you say that, okay, order number 53, please, your sandwich is done in a record time. So what's going on? Now the twist. Guess what? The WebGPU Dall-E and WebGL shares the same kitchen. So what exactly is going on here? Why one is faster and others is not? It's because when you submitted your order in the front desk beforehand, the front desk took time to research your order, to translate your order in a way the chef understands, reorganize all the ingredients that's needed for the order, and next time it comes in, everything is one place, it gets very easy. The same happens in WebGPU. Your graphics driver now doesn't have to do the same work again and again, and it becomes much faster. So it's more upfront work for you, sure, and that can feel annoying, but it's a one-time work, and after that, you reap the benefits every time you do it, and your graphics driver has to do less work, and you also don't have to be dependent on that. So let's look at some of the core concepts of what WebGPU is and the core pieces. This won't be comprehensive, but we'll touch on most of the important things. So the shading language, WGSL. So we mentioned it earlier, but it's worth noting that WebGPU has its own shading language called WGSL. We can spend a whole presentation on WGSL, and but how many of you have played with Rust before? Okay, so this is not required if you actually build programming like use WGSL, but if you want to understand why certain things are the way implemented in WGSL, there's an awesome talk in FOSDEM 2020 by Mozilla where they kind of explain the design choices and certain ways in Rust how it's implemented. So pipelines, we have like mentioned pipelines before. So I'm just going to skip over them. Pipelines are explicitly in a way where you define what your shading and rendering pipelines are. What it enables us is that you can draw and dispatch commands in one go. And this is important because these can be queued. So we have already talked, so these queues can be used in the API, and you submit the commands to the GPU. These are little bunched up and sent in one go, which brings us to passes. When you begin a render, you pass the information, you give it to the, you give the information to it with various attachments it will be outputting to, which we can see on the outside. This is where the clearing happens. As we can see, the multi-sample revolves around these passes. How does it help you as a developer, or like if you have been using WebGL before? So let's do a simple thing about finding a bug in WebGL and WebGPU. If you wanted to find a bug in WebGL, the way normally you used to go before is that you use something called gl.getError, which is kind of like spamming with what you think the error is, and like just looking for it that, okay, is it coming or not? Kind of like Python's print statements, but not exactly. So you just get back a handful of enums and you kind of like wander vaguely around that, okay, this might or might not be where my code is failing. And that's not easy. And if you look for your error, you really have to look for your error, and this is a lot of like hassle. WebGPU makes it much easier to kind of debug it, and in Chrome Developer Console, you will be able to kind of do proper debugs and find that. So some of the tips, which these are not really needed if you just want to build a very simple application, but if you want to build a complex application, this will help you. So as an example, in how many of you have played Doom, the game? Awesome. So there are existing Doom Eternal implementations available which uses that. So it is a well-performing Vulkan game, but if you have more pipelines, it essentially means more switching, also means less performance. Based on your applications, you might not want to do that. And I told about Vulkan because there is a good talk available where the developer actually talked about like how they only use 50 pipelines to achieve what they did. Now, one of the things you can do is that you can create your pipelines in advance, very similar to how I talked about the sandwich demo. Since you are doing it in advance, it's already done before it actually goes there. And not only that, you can also use something like pipeline async, which literally doesn't put you into any queue. You can also use render bundles. Render bundles are kind of like pre-recorded scenes, which you can actually reuse partially. So if you have something like render bundle, this will you will be able to again call it back again and again, and you will be able to use that. This performs best when you get something you are drawing every frame and only varies by the content. This is not something you want to use in every scenario. So be aware of where you are going to use that. So if you want to have learn more about the additional resources, these are some of the resources where you can like learn more about it. And I will share the slides later, so you will be able to learn more about that. Now coming back to our old demo, I also told that, okay, you will be able to build your own like same demo if you want. So what did I have to do that? This will need me to change a bunch of screen shares. So give me a little bit of time. So this is a collab notebook. I will share the links afterwards. If you want to build something, this is specifically for the stability diffusion demo. If you want to build something like this, you have to go through a bunch of steps. First is that I kind of train it here based on like how you compile the stability diffusion model and how you actually make it something which the web understands or which the TVM understands. There are a lot of things here which are properly documented, and if you go for any stability diffusion collab, like a stability diffusion demo, you will be finding most of the steps very same. I just took it from the existing ones, except the reason I'm not going through the whole thing. So here, these are the things, these are the optimizations you need to do to make it run for your web. If you see here, the actual steps are not that much. You just compile it very specific TVM specific commands, and it will generate the JavaScript for you, which you will use in your application, and it will run it. So a couple of caveats, which is that you have to use Chrome version 114, or if you're using a version older than that, you have to use a Canary version, because WebGPU actually went into stable in this Google I/O, which happened just like a couple of weeks back. So if you want to use it, you have to have Chrome 114 enabled for that. Having said that, let me share something else. So this is where I was playing with it. So this is running in my local host, and okay, so how I planned initially was that I'm gonna disable my internet and show you that it still works. But if I do that, my baby will go away. So you have to trust me that this is not actually doing like any internet calls, which I can actually show you, right? Where is the network? Okay. So this does take time.
We're not streaming your slides anymore after you change the sharing.
Okay, just give me a moment, which should be. We are sharing right now, right?
We're not seeing your screen right now.
Yeah.
And now we are.
Okay. So you can see in the network tab, there was no like network connection present. There was nothing going out from my machine, or at least this tab, and nothing going out. And you see this is running. So this is running completely in my machine without using, like it's not using anything server or anything. That's why you don't see any network calls. And it's generating something. I'm using a smaller model. If you use this demo, you can choose a bigger model. My machine will probably crash. Last night it did when I tried a bigger one. So some more things to mind. If you are going to play with TVM, be careful. This is a scientific project. So how it does things is your browser will not expect. So you won't get a browser crash. At least I am getting a Mac like black screen of death. I cannot actually read what's generating. I hope, Lucas, that is a good ending speech. With that, I will end my talk. If you have any questions, I will be hanging around. And how do I go back? Okay, you come back. Here. Go back. And thank you. If you want to get in touch with me, you can find me in my LinkedIn, my email, my blog, and in my Twitter as well. I don't know how many people are using Twitter anymore. But yeah, if you have any questions, I'll be hanging around, and I'll be happy to answer your question. If you have, I have maybe a couple of minutes. So yeah, if you have any questions, I can also answer now. No. So this one is called.
I'm going to be introduced to the great.
Yeah, this is called Red Pajama by Insight. So there are two versions of it in the demo. So if you want to play with it, you will see that there are two versions. One uses 16-bit floating point, another 32. So based on your machine, one might be faster, and one might not be. For mine, it is 16-bit. So if you have a older Intel Mac, 16-bit version will work fine for you. If you have a good machine, try the Falcon one. That is the that is a bigger one. Yeah, that's a 7 model, 7 billion parameter model. So that will be the bigger one. That will produce a much better text as well. But if you have a good machine, try that. It should run fine. So yeah.
So like general for machine learning tasks, we use like CUDA and install like bunch of CUDA libraries for TensorFlow GPU. But for WebGPU, you said like it directly supports NVIDIA. So how does it work?
So all of those abstractions are taken away from you. So in your machine, you have to install CUDA because CUDA is the programming language the NVIDIA understands anyway, right? But your browser already communicates with the graphics engine, because otherwise you would not have even seen your Netflix video or those kind of things, right? So those are already there. How you communicate with it is that you can use TensorFlow.js, which has those things. So it just communicates with your browser. Browser handles the remaining part. Previously, how browser used to handle it using the WebGL, now it handles using WebGPU. So you don't have to worry about the CUDA or installing any of those. Those handshakes are already done. So you just write code which should be technically like a cross-platform compatible.
Awesome. Thank you so much. If you have more questions, then I'll be gathering after the sessions out for some pizza in the area out front, and so you'll have access to all the speakers then. And now we have Kanchana, who is from Google. Did I just pronounce your name correctly?
That's fine. I go by Kanch, but
Kanch. Well, actually,
yes.
let's just call her Kanch then. For Google, who will be speaking more about generative AI, which is all of our favorite topic at the moment. Let's see.
Attach cable.
Attach cable.
Okay.
And make it. Let's see what's happening here.
Okay. Yeah.
Boom.
And then share
And
screen.
then share screen.
Does it share the complete screen?
It'll share what you want. You can share like a window.
Okay.
Yeah, exactly.
I just want to share.
Perfect.
So, okay. Okay. Why share the presenter screen as well? Stop sharing. Oh,
It's mirroring right now.
Yes, I got it. Select a tab to share.
Yeah.
Shouldn't that share just there?
That's sharing it in this, but
Yes.
on the screen, you're still mirroring, so it's showing your whole screen on the...
Oh, okay. So I can do the presenter view then?
You can change it to not mirror.
Oh.
So stop the mirroring, and then we can drag the presentation window over there.
Okay, got it. 1 second.
Yeah.
Stay with me here.
Okay, no problem.
Okay, got it. That's good.
And then make that full if you can. Of course, you can't find the little green dot.
Oh my God. this
Yeah,
is-
it's yeah, you got it. You got it. Okay, perfect. Okay, I think we're ready to go now.
It just needed
Awesome.
2 engineers to figure that
No,
out.
we've had
That's
several
good.
technical difficulties today, and we appreciate the questions, but I think we're ready to get started now.
Okay, 1 second where I figure out where my, okay, good. Okay. Hi, everyone. Oh, you can hear me all okay, right? I go by Kanch. I am an AI innovation program lead at Google. I have been with Google for 6 years now. Prior to this, I was an AI specialist for the New England region. What does it mean? I work with Google Cloud customers on their innovation journey to Google Cloud. That is my job. And since generative AI has started, this has kind of become our life for the past 8 months, I would say. We all heard the previous talk. It was amazing. But mine is going to be at a higher level. What are the things you would see in the businesses today? Because I work with a lot of enterprises in and around New England and other, organizations. So I'm going to have a lot of discussions about how this is impactful in the enterprises, why should we care, and what are the things which we will look for. It's going to be a very high level one, but I'm happy to dig deep into if you want to have a side level conversation. One thing to note is my journey. If you have looked at please connect with me in LinkedIn, but if you look at me, I started in green screens. For those of you who are young, who probably have never worked in green screen, might not know, but I was a mainframe developer in COBOL a long time ago, and then Java, and now generative AI. So I have seen that evolve, and I'm so fortunate to be here, to be able to give this talk and learn from everyone as well. So as I said, it is the talk of the town. We all know that. In this session, we just would cover about the enterprises. What are the buzzwords? What are the things you would need to do today? But I do want to add a caveat though. Whatever I discuss today, it is as of today, because this is an evolving space. What I mentioned today might not exist tomorrow, or maybe there is something better. And I created this slide last month for some other, discussion. I had to make some updates to make sure it's current. So there's a lot of things, which has changed. I'm looking forward to share my learnings, but at the same time, I would like to learn from you as well, because there's a lot we don't know. So it's better to learn together. So we have all had the previous discussion. So you have all heard of generative AI. So that is pretty clear. But can you, at least 4 or 5 people, can you tell me when someone says generative AI, what comes to your mind? Just because you're in Google, okay, you got it. Bard and ChatGPT. You said ChatGPT, okay. ChatGPT.
Similar to the content that the model was trained on.
Okay, that's good.
Large language models.
Okay, yes. So we're going to talk about all of this. And for the people who said ChatGPT, thank you for being honest. I appreciate that. And that's more important than anything. So thank you for being here and, sharing that. So our first, now that we have heard it, so when you see this picture, what comes to mind? Sorry, library. Knowledge, library. Yes, yeah. So I see a lot of young crowd here. So I'm going to throw this question. How many of you have gone here to do your research? Oh, you did? Okay. Okay, so I got one answer. Let me see how many of you have gone here to do your research. So, okay, now I see. So, in 1998, two PhD holders developed a search page which eventually brought the all of the World Wide Web at that time, which is less than 100 million pages, into one search engine, is what we use today in SearchRank. For folks who have gone through that journey, knows how even I'm going to be honest, I was in that phase. I used to go to a library to be able to do a research, and when this came, I was like, is this real? What they're saying, is that real? Can I trust this? Can I trust the source? Can I be able to trust that link? This is what our generation went through. Look at this picture. Tell me, what is the observation you see here? Sorry?
Different time zones, like
Okay. Excuse me? Train station? Okay. Okay. I think I didn't get the answer what I wanted. So I'm going to put the next screen and you're going to immediately tell me what it is. Sorry? Excuse me? Yes. So no one in the previous screen had a mobile. In this screen, everyone has a mobile. I don't know if you remember that world. That world existed where we didn't have a phone in our hands, where we didn't connect with anyone, where we are not watching, where our data points are not being tracked or being used by anyone. That world existed in our generation, and we did see that. So these two major evolutions in the world happened right in front of us. And now, let's talk about how the future is going to be. And we are all in this room are going to be part of this future, which the world you see today is not going to be 3 years from now. I can guarantee that. Because the evolutions which are happening is very, very obvious. This is a chart where you could see in the last couple of slides where we talked about mobile revolution, internet revolution, things like that. It took a while. Sometimes it took 3 years, sometimes it took 4 years. I was in India when the internet revolution was coming. At that time, it took quite 5 years, I would say, before I could get a hands-on to those days AOL or things like that. At that time, it took time. But ChatGPT, in the first day, they had 100 million followers. That is the revolution all of us are seeing in this world. For a comparison scale, I don't think it exists here. Pokemon Go took 19 days to get to 50 million. So that's the comparison you need to do. Because as soon as I put this slide, people would say, but you can't compare Netflix and this. They would say, but Pokemon Go it's real, guys. It is real. We need to accept that. This is a revolution. It's coming. So we need to understand, how can I make this hype to real? All of us in the enterprises, whether it's Google, like Google again is an enterprise. Now we are 20 years old. We need to accept that. We are old. We are no longer teenagers. We can't be making choices. So we need to accept that. How can we fit in this world where everything is going to change? So this is the market research run by President's Research, but you could pull up any kind of market research you would see. It's expected to be 119 billion in this decade. Just this year, in the first 4 months between January through May, the Gen AI app is about 1,480% in Apple. That shows how we are adopting. So in all of this, I'm showing what the predictions look like. But us as a learning community, we need to learn how can we prepare for it. So, and then I'll show a little bit about enterprises, but this is something which we should learn. So what is generative AI? And many of us here probably know some of this, but it's just some brainstorming, some of the concepts. So feel free to ignore, or you can follow along with me. Prior to generative AI, most often when I go and present, this is one of the slides I present, right? Where I talk about how is artificial intelligence, what is machine learning, how it all comes together, what are the phases. So we always talked about, if you look at, natural language generation, it always existed. It is not new. But the concept of generative AI was, created after 2014 when Ian Goodfellow coined it in his paper. But these concepts, if you see voice synthesis, if you see natural language, if you see image classification, all of this existed before. It's nothing new. But now we started with the recent hype of ChatGPT. All of these, use cases, models, or whatever they call it, have started coming into picture. And in today's discussion, our focus is mainly only going to be in the natural language piece of it, because there's so much to talk about, and I have only exactly 8 minutes left. So I'm going to try to hurry up, but there's a lot to uncover here. But this is one slide I want all of us to, keep it in mind. I think someone here mentioned it, the ability to create the content. So what does it create? How do you access them? What is the algorithm? There are a couple of things here you need to note, because that is what is important when you think about generative AI. And I'm going to take one step here, and let's start with how generative AI is generating the content, right? So I am at We Decided to Play. And the generative AI needs to decide what the next statement is. It's going to decide based on the content it has seen before. Without any context, the LLM is writing. So it could be game. It could be in, because it doesn't know. It could be ball. And now LLM has to decide between one of those words. It's going to make a probabilistic assumption, and it's going to give the most out of it. And there are, scores and things which are used to decide that, but it's based on all the decisions it makes, it decides. So this is important. We need to understand that LLMs are fancy autocomplete. It doesn't know anything. It doesn't have the sense of what is right, what is wrong. These are fancy autocompletes. And I have heard people who say, hey, I need to be able to, have this medical thing to be checked. And I'm like, you're checking medical in ChatGPT? You must be crazy. But there are people who are doing that. So we need to have that in mind, that this is a fancy autocomplete. It doesn't have any sense. And as you are developing, or as you are thinking that through, it's important to differentiate what is real, what is not, and be able to do that. There are some building blocks, and I am very cognizant of the time, so I am running, and I'm not using my actual track. So if you have any questions, happy to talk later. In a pre-generative AI era, this is what I used. If there are data scientists in the room, don't call me out on the mistakes. I know there are many mistakes are there. But these are the high-level building blocks here, right? Where you are looking at the data, exploring the data, identifying what is all of that. Okay, but on a Gen AI era, this is the things which we have seen evolve. Okay, I have time, guys. I have been granted. The Gen AI era, I'm sure you have all have heard of the prompt engineering, because we all saw in CNBC, that's the new role which is coming. So it must be real. and then the foundation models and things which exist today makes Gen AI era a lot more democratized, because you don't have to be, forgive me if there are data scientists in the room, but you don't have to be a data scientist to create some of these amazing products. All you need to do is to be a decent developer, and I am a decent developer, that's it. But I can do things which I haven't been able to do it for a long time. So things are changing in the way how it's going. And let me give you an example. When this chat GPT, all the conversations started, everyone was like, okay, chat is the new thing. The conversational AI is going to be the new thing. And then, I don't know if you've heard, chaining came into picture. Then it was lang chain is the new thing, and this is what is going to happen. And then agenting came into picture, agent GPT. I don't know if you all saw that. And that came into picture. Everyone was behind it. And yesterday, I saw this a new company, Mid AI. What is it? No. Yesterday, there was a valuation done for 165 million with no direct Series B. It starts with mid. So yesterday, that was a new thing. So things are progressing at a speed which you or I cannot imagine. So this is real. Again, I keep stressing on that this is real. We all know it's real, right? So this I took from Hugging Face page, and this is a concept which all need to understand, foundation model. How many have heard of you? How many of you have heard of foundation model? Okay, quite a bit don't know. That's good. So in generative AI, the most important thing you need to know is foundation model. GPT is a foundation model. There are a lot of foundation models which exist today. And creating a foundation model takes a lot of resource, not just compute, not just memory. That it takes a lot of resources in general. And there are several examples of foundation models which we will go through in the next slide. But I do want to stress, because I am in Google, we are all in Google, so I just need to say this, that Google wrote this paper, guys. Attention is what you need. That's where it all started. So the T in GPT is from Google. So we kind of share the limelight, I guess. So the folks who said chat GPT, thank you, because somehow we are connected. So for example, if you recall, like, years ago, if you need to if you go to Google search, I don't know how many of you have done it. If you said restaurant recommendations, I need to be able to clearly say restaurant recommendations, and I need to give the zip code 01, blah, 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 right? And then there came a phase where I need to go and say restaurant recommendations near me. I used to say that. Now I just go and say restaurant recommendations, and it exactly knows where I am, and it exactly tells you what my preference is, which is real, right? If you think about the evolution which we have come, it is based on that paper. Attention is all you need, because it's able to connect what the person is asking with the context and give that information. That's how it was built. So the foundation models or things are used in practice in Google, and that's how it's evolved. So I want to share the screen of the journey of all the foundation models and how it's developed. It's important to recognize that, because most often folks, because like it's real, the chat GPT has been in the news, in the media, everyone talks about it. GPT is the only one which is known, but that is not the case. There is a lot of models which exist, and we need to explore and use. Why do you need to know this? Because you might not need to know Taylor Swift's all the lines to develop an insurance product. You don't need that, because you don't need the list of models, right? So you need to be able to pick the foundation model which is designed for that purpose. That's why if you have seen Bloomberg created their own GPT called Bloomberg GPT for financial reasons. And if you want to use for math, you use a math GPT. You are not using a large foundation model, then there's no need. Google might need, because they are developing Google search. But if you are, say, in an organization and you're working, say, for, I'm just picking a company. I have no idea if this company is doing this or not. But say you pick a retail company. Say if you are in TJ Maxx, and if they are doing it, they don't need to know the large language model. They need to be able to understand what they want for their customers and be able to build it. And if a customer was rogue enough to ask what are Taylor Swift lines in a TJ Maxx website, then it's up to them how they handle it. But you don't need to know it to create the model. But these foundation models are important for you to understand. And I really like this tweet. That's why I copied this, because the hottest new programming language is English. And that is for sure, not just because prompt engineering, because now you all might have used Code-E or other code generating techniques, even ChatGPT or Bard. You go in there and you say, how do I generate this piece of code? And it just gives you the code, and then you intersect with your language, right? So you kind of need to know English to be able to do that. I'm sure other languages are coming. No offense to other language, but just this is one prompts where we use natural language to be able to create the questions and generate the output is going to be the future. So I'm going to start with some of the prompting techniques, and it's going to be very basic. You might have already known it, but I will share some resources where you could go deep into it. So we talked about foundation models, which is very, very important in a Gen AI world. And I would encourage all of you to go and look up all the foundation models which exist, which is reference for what, particularly the ones in Google, which because I work at, I am exposed to Google products. I would say that Bison, Palm, all of these have insane amount of capability, which doesn't get the publicity I think it deserves. So my first question, if at all you have ChatGPT or Bard in front of you, I would encourage to use it. But if not, that's okay. I'm going to just say first one, create an itinerary for a family of 3. This is just prompting. And if you have used ChatGPT or Bard before, you probably have experienced this. And when you enter it, most likely the result you receive is probably in US. And that is, now let's go, that's probably the case. If I go one step further, I'm giving context to it. I'm saying I am in India, create an itinerary for family of 3. And that is context prompting, giving context to the prompt and asking question. I'm going to try a slightly different approach. You are a sales representative for Southwest Airlines and create an itinerary of family of 3. If you do that, then you're doing role prompting, but you need to remember, in this instance, it's going to give you the itinerary of places only where Southwest Airlines flies. That is really pivotal in organizations, particularly when you're working. Giving that context makes a lot of difference. I'm going to do few short promptings if you have not heard again. In zero-shot prompting, you're asking a question with no examples, and you're just saying, add 2 + 2. It would say the answer. And if I give an example, in this case, one example, 3 + 3 is equal to 6, and add 2 + 2, it would give an answer. Sorry, guys, if you have tried this in Bard, please forgive me, because it said, are you kidding me? It did say that. But do this in ChatGPT, that's the case. And allowing a person to, practice the task is fine-tuning. So these are a couple of techniques which have evolved over the period. I would encourage it, just keep looking at these topics. If at all you need to get expertise in generative AI. These are important topics, particularly the parameter efficient prompt tuning or fine tuning is coming more and more very relevant in organizations, but which use generative AI. So I have gone through the important things with respect to generative AI. I will take about 5 minutes to go through the enterprise landscape, but I do want to, answer any questions you might have. So the enterprise landscape, this comes from a Sequoia article. And if at all you're not following them, I would suggest follow them. The only reason is because they have been in this generative AI venturing long before generative AI was a thing, since 2014, I guess. So they have been following this space, and they have identified a lot of use cases you see in here came from them. And they have definitely shared a lot of thought leadership articles, which is really impactful. So is it all good? No, not at all. It comes with a lot of concerns, and I do have a lot of concerns. If you follow me in LinkedIn, you probably know. But the copyright issues are, there. Hallucination, if you have not heard of the concept, making things up, it does a lot. Prompt injection and biases. All of these exist today, and these are pitfalls which we need to be aware of as you and I, as we start developing the Gen AI products. So some of the considerations I like, just me being in this space, working with enterprises, these are some things which I think about when we are, thinking about Gen AI product development. And most organizations you have here, you probably are following or you know what they're doing, but I would recommend follow these companies because they're all doing an amazing job. But if you ask me how this is going to evolve, I would definitely say, like if you're not following NVIDIA, it probably is a good time to follow because they have been doing amazing in this space. And if you look at other companies, there's a lot of integrations happening. Salesforce is integrating, Jira is integrating, Stack Overflow, Core, like every enterprise product is being integrated with LLMs. But these companies provide a place for the other enterprises to evolve. I'm going to do one last resources sheet, which of course I'll share it later. But there are a couple of good content out there, which is up and coming. Again, this is as of last month, so maybe there is other few I can add as well. So the measure of the intelligence is the ability to change, and we all need to change because change is coming. And I would appreciate it if you take a few moments to give me a feedback in this form while I answer your questions. Is there anything I can, it's 28:54, I'll take 3 minutes. Yes, please.
You mentioned working with enterprise on pitfalls as well as the most promising applications. Do you have any standouts there to call out?
Obviously, I can't share anything, NDA. But I do see that the common pattern which you see evolve is in things which are in sales and marketing side of the things, because the companies are worried about disrupting their core business. So they're starting with sales and marketing. We see that evolve a lot. And if I see 1 year from now, you probably would have a lot more personalization than you do today, for sure. Yes.
What do you think is going to be the biggest change that this brings into our lives?
I don't know. I am more worried than optimistic, honestly, because I saw yesterday there was, I think it was in Reuters or somewhere. It was, this is more me creating worrisome. So please ignore me if you don't want to hear that. But it talked about how a person thought AI was a romantic partner and how that is evolving. And for me, that's concerning. But in enterprise world, I'm very excited. There's a lot happening, and I am so like we should all be so fortunate to be seeing this evolve. Yeah. Okay. 3 hands. Yes.
Let me just jump in quickly. Could you just mention the Google training that's on Skills Boost? There are
Yes.
10 courses now in the Gen AI learning path.
Yes,
And,
I will add that to the deck as well.
And at
there
GDG
is
Cloud Boston, we use the Skills Boost a lot.
Yes, in the Cloud Skills Boost, there is a lot of good Google generative AI trainings which are out there. I myself took 3 or 4 sessions and it was really helpful. So if you want to know further, yes, I would recommend that to take it. Yeah, and then I'll come to you. Yes.
So what's your view on the security of prompt generation? Like we can see now people are developing the jailbreaking prompts, which can affect the
I'm
GPT
going to
models.
pull a Sam Altman out
Right.
there because I did see one of his interviews about this particular topic. And he said he wants to see the world evolve where there is no prompts.
Okay.
And I think that's what we're going towards. Prompts are there today. I don't think in 2 years
Okay.
that would exist. But it is worrisome, of course. But if he's saying it should be right? So there's probably something happening there for sure. Yes.
Probably related. I am worried, like many people, I'm sure, about the bias and whatnot.
Yeah.
The problems you're talking about. So I noticed that, for instance, Adobe had, they've got a product line where
Yes.
it's like, the content we have is very secure. You know what you're going to get. It's, you don't have to worry about copyright or bad images.
Yeah.
Do you think there'll be more and more of that coming out, that people will present it as this is has high integrity as opposed to whatever you can get out on the internet?
So to start with, most organizations have their their AI principles. So if you look at Google AI principles, we have the first one who wrote it. And I can solemnly say that we follow that to the core. In fact, sometimes to the detriment of the product, delays and things like that, we follow it, right? And there are other companies which has it. Microsoft has announced it later, and then there are other companies which we are doing that. And Adobe has mentioned that product. I think the way it's going to evolve, at least in my opinion, it's going to be countries are going to pose a lot more limitations. And we have seen that over the past few, like, Italy, I think, had stopped ChatGPT for like 48 hours and everyone was crying, oh, this is what happened. But then they opened it, right? And then China said, okay, any generative AI product needs to go through an approval process. And then India made a choice not to do that. They decided that this is the way strategies. So countries are going to make a choice. And I think US developed a blueprint, and that's one of the ways to achieve that. I think that's the way it's going to evolve. That, as we know, right, GDPR, right? It's a big concern. Like, as we develop, we are focused on making sure we are aligning to the rules. And that's what is going to happen, I think. Adobe has taken a great step in saying that, but I think the way it would evolve is probably that. So I know I ran out of time a lot, and Lucas is looking at me like, okay, are you getting out of here? So folks, please give me feedback in this form. I really, really would appreciate it. And connect me in LinkedIn. Happy to chat anytime. I do have to run. I would not be able to stay for the dinner. Thank you. Yes, I will.
Okay, folks, we have one more talk. We'll just be starting momentarily.
Did I put it?
Yeah, you can just put it on.
Okay, I'll do it up there.
Yeah. Sorry.
Oh, yes, sorry. Great. Thank you for inviting me. Appreciate it. Oh.
So, yeah, that's it.
I'm guessing the Android track is like done now.
No,
They're not done?
No, they're just starting the last talk.
Oh, okay. Sweet.
The problem is the food is out there, so we're gonna have to start.
Why don't we just give people like no?
Because it's not gonna get back.
Yeah, true.
No, we should just do this, and
Okay.
everyone can go to the social event.
Okay. I need so I need her to make me a host.
And we're probably broadcasting that way.
Yeah. Okay, I need to be made a host, I think, here.
It said you're able to present, right?
It said not able. Okay.
Sweet.
All right.
Okay.
You can. Should I do it now?
I'll just say that to the screen.
No. Okay. Go for it.
Let me just get some. You have one?
Yep. Should I show? Oh. No.
Okay, folks, we're now getting started with the last talk. I'm very excited to have Marissa Fisher here from the Broad Institute speaking about leveraging Google Cloud for precision-based healthcare. And just as a note, Marissa and I worked very closely together at the Broad over the pandemic when we worked on the COVID testing program. And so I'm just incredibly fond of her, and I'm very glad to have her here today. So please welcome Marissa.
All right. Thank you all for sticking around first. I know it's a sunny Friday afternoon and you all chose to come here and listen to talks about AI and cloud, which I'm going to talk not at all about AI. So hopefully you're ready for that. So I'm just going to change here. All right, we're good. Okay, so first of all, thank you to Google I/O and GDG for having this event today. It's great to be here. Thank you, Lucas, as well, for introducing me. And I'm going to talk a little bit about healthcare before I dive into cloud, to give you a bit of context on why we built this system and kind of what we do at the Broad Institute, which is where I work. So flashing back to 2020, we at the Broad Institute got a grant. Am I good?
I think you're good, yeah.
Okay.
Sharing.
We received a grant, basically, which was to provide these genomic risk assessments. So what is that? Well, there's a lot of factors that go into that. There can be things like clinical determinants of like, what is your health history?
Seeing this screen is the problem.
Oh, they are?
Instead of that one.
Okay. I mean, that's
okay.
It's okay.
Okay.
I mean, I don't mind. Yeah, if it's okay for other people. I mean, all right. So yeah, as I was saying, genomic risk assessments take in a lot of different factors when you're trying to understand, like, is this particular person at a higher or lower risk for developing a certain condition or disease? So there can be things like your family history, like maybe your father has had a heart attack, or maybe you had one in the past. There can be things like monogenic determinants, which I think a lot of people probably know of this BRCA1 gene, which is related to breast cancer, which is like a single point mutation. And there can be, of course, social determinants like your lifestyle, where you live, pollution, smoking, things like that. And one thing that we're particularly interested in at the Broad Institute over the last few years, and a lot of other research institutes are looking at this, is polygenic determinants. There's recently a New York Times article on this, and there's a lot of talk about it, of like, how useful are these? How does it have a position in the clinic? And really what it is looking at multiple points in your genome to understand your risk for developing a certain disease. So we, in this particular project, are focusing on 10 different conditions. So that's ranging from conditions of the heart to diabetes and breast cancer and a few others. A little bit more on PRS. This is just an example of for cardiovascular disease, and in particular coronary artery disease. So I found this statistic pretty interesting, that about 1 in 200 people have a monogenic variant that can cause an increase for a cardiovascular event, whereas it turns out about 1 in 12 people have a higher polygenic risk for a 3 to 5-fold increase in cardiovascular risk. And this was backed up by a study done by Amey, who was a cardiologist and closely worked with the Broad going back quite a few years. And you can see, so actually I should say as well that a polygenic score is really just like a percentile between 0 to 100. So the higher your polygenic score for a condition, the higher your risk is for that. So you can see for coronary artery disease, over as you get over that 50th percentile, the prevalence of coronary artery disease actually increases a lot. So we did a lot of collaboration with his team early on, and for eMERGE, we are focusing on other conditions than heart. But getting back to the technology, well, we had to build a reporting system for this, basically. So these scores had to go back to patients somehow. And it was a pretty low scale endeavor because it's only about 25,000 samples over 3 years. But something that's pretty important is that it involves patient data. So it needs to be highly secured. I know a lot of times people think like, oh, cloud, patient data, I don't know, but we do it, and we have been doing it for quite a few years now. And we wanted to also design a system for low cost. Typically, in my experience at least, I've been working on systems that need to be highly scalable, that need to respond in real time, or dealing with massive files of genomic data. This particular system, for me, it was an interesting challenge to think about, like, how lightweight of a system can we really build, and what cloud tools can we use to meet those needs. So this system kind of had like 5 categories of things it needed to do. And this can be applied to a lot of things, not just healthcare. I really just want to illustrate like how to sort of think about building a system and breaking things down. So initially, we knew that we were going to have to interact with some third-party APIs. So 2 of them, one of them being what we call REDCap, or the R4 API, which is, Lucas is nodding yet. So it houses like all the patient data. So when orders come in, patient names, patient barcodes on the tubes, basically anything you need to know about a particular sample goes there initially. And then, have any of you heard of Terra before? Terra? Yeah, some of you? Okay. So Terra is a system built at the Broad Institute, not by the team that I work on, but it's pretty awesome. It runs genomic pipelines at high scale, and it's open to anyone. So a lot of researchers around the world are using it to run their pipelines. And so we as well are using it internally to put the genomic data after it comes off the sequencers, process it, run analyses on it, and eventually to come out with a score. So that score between 0 to 100. The next thing we had to do, well, we had to link those scores somehow to a patient. And we're going to have to also generate reports. So a PDF report, really, or a JSON file. We also need our clinical director to review and sign off on these results. So we're going to have some way to interact with her, some gesture so she could say it's good to go, or we need to hold back. So it was going to be a system where there kind of needs to be pauses and checks throughout. You can't just like steam through it. And then lastly, delivering those reports back to clinicians, patients, hospitals, research centers all through that R4 API and storing our data finally in the Terra API as well, or Terra system. So thinking about this, it seemed to align pretty well with Cloud Functions. How many of you have used Cloud Functions before? Probably a lot of you. Yeah. So I love these. It's like my, I don't know, Swiss Army knife that I use for a lot of things. And I think it's nice because if you can kind of compartmentalize your tasks into small, sort of short-lived operations, it can be really, really useful. So some benefits of these, they're serverless. There's no need to manage servers. You can really just focus on the code. In our case, we're using Python. It's great for short-lived spurty tasks. So you can scale them up to handle the load as needed, but they also don't do any work when you don't need them. So compared to something like Compute Engine or Google Kubernetes Engine, which are always running, they're event-driven. So there's a lot of different ways you can invoke them. Some being just by classic HTTP requests. You can also do it by files landing in a cloud storage bucket, or cloud tasks, I think is a more recent addition, as well as Google PubSub. And I'm sure I'm probably missing some. There's probably more ways to invoke them now that they've added. They're also super cost efficient. So you only get charged for what you use. I was looking at like the highest memory level, and that was about 16 cents per minute. And you can keep your memory low as well and lower that cost too. It's got a nice integration with other Google Cloud services. It's also really easy to incorporate with your CI/CD processes. So if you use Cloud Build or you're familiar with that, you can write just like one YAML file, deploy your Cloud Functions pretty nicely. And also you could do it through the command line. You also get logging and monitoring right out of the box. So you write a print statement in your Google Cloud Function, and that's going to be output to cloud logging. You just have to be careful because you can like log a lot of stuff. So it's good to have a bit of strategy around that too. A couple challenges with these to keep in mind if you decide to use them in your day-to-day jobs is you do have to keep it within the 9-minute runtime limit. And it has a 16 gigabyte memory limit, which I thought was actually pretty high, higher than I think that's for generation 2. So generation 1 is a bit lower. And you can actually like hit memory limits in surprising ways. So I found that by having a single cloud function that invoked a bunch of other cloud functions. So I wanted to like kick off a bunch of other ones in parallel. So have one who's kind of like the distributor, and then kick off as many as needed of the next step. That was hitting our memory limit on that particular cloud function. I don't remember what the exact value was. It definitely wasn't 16 gigabytes. It was lower. So we thought at that point, we could increase the memory on this, or maybe we can try something else, because I don't want to just keep increasing memory. So what we incorporated at this point was something I hadn't used before, was Cloud Tasks. So Cloud Tasks is like a queuing system. I find it's similar to PubSub in some ways, if anyone is familiar with that too. And so what we did to kind of solve that issue of the memory limitation was queue our report uploads to the different APIs, so the R4 API and the Terra API. And so one cloud function could finish and the jobs could still be going on and processing for those other cloud functions downstream. So that's different in that I've experienced before where you kind of need to keep the originating cloud function alive for the downstream processes to kick off and finish. But in this case, with Cloud Tasks, that can be totally offloaded. It also has distributed task orchestration. So in this scenario as well, we could send our reports out to the patient portal first, and then we could send the data to Terra later, because we don't want to be sending data to Terra before we actually generate the reports. So you can order things nicely. It also integrates seamlessly with Cloud Functions. And you get retry and error handling configurable as well. So I think we set ours to like 3 retries. I don't know what the limit is, but probably you don't want it to retry forever. It's also really low cost too. So it's 40 cents per million operations. I don't think we're even gonna hit 1 million operations ever for this system, so it's essentially free. And some other benefits we don't take advantage of. You can have asynchronous notifications to send out emails or notifications that won't stop or block your app flow at all. You can schedule tasks for a later time, and you can also pause tasks if you need to. All right, so another interesting thing about this system is when it came to storage considerations. So, you know, a lot of times you design a system and you need a database, or you assume that you need one. That's an assumption that we kind of made from the beginning, but as we were going through this, we thought, I don't think we actually need a database for this. We're really just storing CSVs that contain genomic data, JSON, and PDF files. So we thought, why don't we just leave as much PHI as we can? So PHI, for those who don't know, it's protected health information. So anything about a patient that is, you know, unique to them is considered protected. So if we could just leave as much data as possible of that in the patient portal, so that R4 API, and pull it from there if we need, rather than storing it internally, that would be great. So we decided to try and go down that route, and we did. And really, we just pull PHI in at the end when we need to make those clinical reports that the patients and the doctors actually see. So in the end, we had no need for a relational database. I think there are some challenges with that, but definitely can keep costs down, and kind of simplify design in some ways. So this is kind of small, but this is our general architecture. The point here is that we're using a lot of cloud functions and cloud storage buckets. So the cloud functions are those ones that have like the little 3 dots in the middle, and then the other blue, what are these, hexagons, with the horizontal lines are cloud storage buckets. So we have data kind of coming through from the lab and from the Terra API, which is just a file containing the polygenic risk scores. So we process that, and then I guess you can, yeah, you can see my mouse here, cool. So we process that through this cloud function, which gets kicked off by a file landing in a storage bucket. We then use cloud tasks to distribute that. So say we've got, you know, between 200 to 300 scores that just came in, we need to route those, pull in the correct data so that it can be reviewed by our director later. So that data kind of lives in this bucket here. And then on a cloud scheduler, which is another way that you can invoke a cloud function, we batch them together into a group and present them into a pretty lightweight user interface. It's App Engine, Firestore, and Google Sheets. So I guess I lied, because we do have a database. It's Firestore. But it's really, I don't know, to me it's more like a key value store. So we're really storing like a batch ID and a Boolean, like true or false, was this batch approved? And then again, we're using cloud tasks later on to route the reports either to the R4 RedCap API or back to Terra down here. Yeah, so that's kind of just a summary of the different tools we're using and how they interact. But yeah, I did mention a UI, right? So I don't know how many front-end developers we have in the room, but as a back-end developer, I hate doing front-end stuff. So I'm always looking for like the easiest way to get out of doing it. And to me, App Engine is awesome because literally I didn't have to write any JavaScript or CSS. It's just Python and HTML. So if anyone's looking for a nice way to, well, I'm sure it supports other things in Python. I don't know. Yeah, so we integrated that with Google Sheets. And then, as I mentioned, Firestore. So when reports are ready to be sent out, we send the data in this spreadsheet for the clinical director to go through and review. So they just basically look at these, select or deselect which samples should go through. If anything looks weird, they can hold it back. So it's really nothing spectacular, but it does the job. So a lot of work goes into that, given that, we didn't really like doing front-end stuff. But as I am looking for other ways of doing things, I noticed in the I/O this year, they talked about app sheets. Has anyone tried that yet or hear about it? Yeah, you did. So not quite on like the, generative AI level, but I was curious, like how could I get an app quickly that does what I want it to do rather than and not have to write any code at all. So in app sheets, you go in and you answer a few prompts. So I told them like, hey, I want an approval system for clinical results. And I said, I want to be able to manage those results. And I want to be able to send those results. And this is what it gave back to me, which I didn't think was too bad. So it has like a list of results. I can select or deselect them. And there's a little mail icon, which I suppose I could program to send somewhere. So I don't know. Again, don't want to do front end stuff. So it was kind of nice. The other thing I want to talk about is how we did our CI/CD. So we were using a combination of Terraform and Cloud Build. So all of our resources we use, except for Cloud Functions, are managed by Terraform. And then our Cloud Functions and App Engine code gets deployed by Cloud Build. So with that, if anyone's used Cloud Build before, if you haven't, I think it's really a great tool because you can just write a YAML file. And in our case, we use GitHub Actions. So anytime you make a change to those Cloud Functions, you push your code up to your develop branch, let's say, and it'll automatically kick off and deploy to your develop environment. Oh yeah, and also they announced there's like more support between Terraform and Google Cloud Resources for Firestore. So it seems like they keep increasing the things that you can configure with Terraform, which is pretty awesome. So at the end of the day, what did we get with all this? Well, our production system costs less than $4 per month, which I thought was pretty cool. We have a system that has very little PHI interaction. I think if you ask any information security team at any company, they're going to tell you the less personal data you can store, the better. So there's no expensive, bulky database needed either. We have a lightweight UI, no JavaScript, no CSS, just HTML and Python using App Engine. It's fully CI/CD, depending on Terraform and Cloud Build. We had some issues with Cloud Functions and used Cloud Tasks to work around them. And of course, some challenges with third-party APIs. So, one day if the R4 API decides to take 9 minutes to respond, well, my Cloud Function might time out. So that's an issue. Doesn't happen too often, thankfully. But yeah, and at the end of the day, we have a new framework that supports the next generation of clinical tests and this polygenic risk scoring. So yeah, and none of this, of course, would be possible without the eMERGE Network participants and consortium and the Broad Institute. And thank you to GDG and everyone here today.
Thank you.
Thank you.
That's amazing. Actually, there was some stuff you said that I didn't realize until I saw your talk, so I was like, oh, that's not good. Okay, so we're just wrapping up here. I can get my computer plugged in. But not to shut down. Thank you all for participating today. This has been so exciting for us. Oh, Norbert wants to clip a microphone on me. But this has just been such a great experience working together with the 3 GDG organizations and then having you all come attend in person here at Google. So I really wanted to thank you all. I can go to slideshow mode, I guess. We have a Slack workspace for GDG Cloud Boston, and we would love to have you join the workspace. This is a place where we can chat and interact together in between the events that we hold. This is also a great way for us to like ping you if there's like an update on the event, or for today, I really wanted to tell people like when we needed you to arrive by, and I didn't have a great way to do that, unfortunately. So we would love to invite you to join the Slack. You know, you can type in the link or just take a picture if you want, and we will see you on there. Also, we have a bunch of other ways you can connect with us if you haven't already. We just created a LinkedIn company, which is we've had a LinkedIn group for a long time, which are also welcome to join. But the LinkedIn company is fun because you can like at us, you can like mention us when you're writing a post, which you can't do with a group. So we just added that. We've had a Twitter for a while, and we try to advertise all our events there. This time we even created a tweet for each of our speakers, which is something we're going to be doing going forward. And also we now are on Instagram, which is new for us. So we're going to be trying to figure out how best to leverage that. And then what we've been trying to do, especially for these events where we have a virtual component, but in general, we've been trying to make recordings of all of the sessions and make them available on our YouTube page. So all the sessions from today will be available on our YouTube page. So feel free to check us out there. And I apparently have some QR codes that you can use if you need to try and grab any of those. I'm not 100% sure if that'll work from your seats or not, but hopefully it will. And then this is the wrap up, y'all. So we actually have food outside, and you're all welcome to stick around for like the next hour or so. We'll be shutting things down at 8, but please feel free to network and socialize and talk to the speakers, ask questions, and meet some of the other community members that you're here participating with. And thank you so much. That is the end of the stream. We can say goodbye to our friends online and shut off the feeds. Thank you, Norbert.